Hi, it's product review time. We're going to take a look at a brand we haven't looked at before. I don't think so anyway. Thank you very much, Ziboo, for sending this into the mailbag. Thought I'd do a dedicated video. Looks like it's a rip-off, basically, of the Fluke 17B Max. I've done a video on this. It's not a bad meter, about 130 Yankee buck class meter. This one's about 50 Yankee buck class. Sorry about the voice at the moment. I think I might have lowered one octave. So obviously it's not an exact match, but of course they're trying to match the number here, 17B Pro. They didn't pick that randomly. They're trying to play off the Fluke 17B. So a $50 class meter. It's available worldwide. Is it a Fluke Yellow like this? Because if it's the Fluke Yellow, good luck getting that past the US customs. Just ask SparkFun about that. It's available in the 15B. Don't know why you'd buy that one. Save a few bucks. Just doesn't have temperature. That looks like the only difference, so why bother? And there at Ziboo online here, you can scan the barcode, and they also send in this matching clamp meter because it looks like it supports a clamp meter, so we'll check that out. Looks like the red dot indicates that this is not trademark infringing. We've got red here. Got a dodgy looking K-type thermocouple, just some ordinary looking leads. We'll take a better look at Ziboo 17B Pro. There it is. It's high precision. Well, I doubt that. But whoa, 1500 volts? Yeah, 1500. That's interesting. That's a nah on the high precision. We're talking basic 0.5% accuracy at best, nothing special, 0.8 on the current, etc. But, it's on par with the Fluke and the other, 6,000 count meters is true RMS, but it has bugger all bandwidth of, 1 kilohertz. Meh, at least it's true RMS. What? Bluetooth function? No. Doesn't have that. Yeah, they're really talking up the 1500 volts DC here. Alright. And sure enough, there's their comparison. 150 bucks, you can get it a bit cheaper. 40 to 50 bucks, you can get it a bit cheaper on special or whatever. But basically a third of the price. It doesn't matter that it only goes to 40 instead of 60. Yeah, the capacitance wasn't very good on the 17B Plus. I think that was one of my criticisms there. We have a note. Hi Dave, greetings from the Ziboo engineering team in China. Let's be honest, most budget meters are absolute crap. Yes, they are. But, you get what you pay for. We tried to change that. We built the Ziboo 15B and 17B to be affordable but safe. They actually have proper input protection, MOVs and real fuses inside. We know you love to blow stuff up, so please give them the full torture test. I can't actually, I don't have like a real high energy. I've got high voltage testers here. I don't have any like real high energy ones to actually test, massive fuse surges and stuff like that. Unfortunately, if the magic smoke comes out, we deserve the roast. If they survive, hope you like them. Yeah, I don't think I have the ability to make the magic smoke come out of this, but thank you very much. But I can test at high voltage, just, not the blast rating of the fuses. We've got two separate manuals. One is the quickly user manual. Well, we want to learn it quickly. I won't bore you with all the details, but there you go. For those playing along at home, you can pause it. And the other side, there we go. Whee! Well, as you can see, it's got a very near identical form factor in terms of look and feel, and the rubber holster. It is red instead of the Fluke Yellow, but I have seen that they do actually make a yellow version of this, but I'm not sure if they actually if it's still available or whatnot. As you can see, it's not a direct one-for-one copy. I mean, the jacks are staggered like this, whereas we've got inline over here. We've got extra functions. This has non-contact voltage testing, which the Fluke doesn't. The Fluke has a separate relative button here. This one doesn't look like it has a relative button at all. If not, that's a showstopper. And the functions are in different positions, like a dedicated temperature down here, whereas it's on the typical millivolt range here. And, like AC is a separate thing, whereas you have to shift function to get it on this. So the Fluke's more better there. And they're both Cat 3 600 volt rating, but of course you're going to believe the Fluke better than this one. But there's only one way to find out. You know what we say here on the EEVblog, don't turn it on, take it apart. Before I do that, we will have a look at the back here. Quite similar probe holders like this. It's got a attachment up there for a lanyard thing, which you don't get with it. And our tilt-in balers, well, it's a little bit wobbly. And this thing actually weighs significantly less than the Fluke. And it's a little bit more wobbly than the Fluke here. Trust me, you know, you need feeler vision to see it. But, you know, the Fluke has a bit more heft to it than the Ziboo. 3 AA's in here, not supplied, so it didn't actually work out of the box. Metal threaded insert for the cover. We've only got the 2 AA's on the Fluke, but on the Ziboo, we do actually have the fuse access. Look at that. We've got 2 ceramic jobbies there. That's rather nice. So let's crack it open, see what we've got. Of course, we're not going to have metal threaded inserts here. That's a nope. Well, here it is inside, and I gotta say, it looks neat and tidy. We'll compare with the Fluke in a second. Now, here's the case. It does actually have the extra blast protection, which goes in around here. That's nice, but then you could argue that with the exposed fuses here, with just that on the back of it, that's the sort of little bit defeats the purpose of that. So the Fluke meter in this regard is probably going to be better from like external blast protection point of view if the fuses do pop. But as you can see here, the Fluke do use the big 30 kiloamp wider jobbies here, as opposed to these are still pretty decent. They're not little M205s, and it looks like they are actually ceramic fuses, so that's not too shabby. These fuses are from a company called Reassembly. I haven't heard of them before, but I'll put up the data sheet here. They do seem a legit manufacturer of ceramic fuses, and there's no ident on the other side here. They do have multiple different series. I think I've got the correct one here. The great news is these are proper 1000-volt fuses. So, yeah, I'm surprised to find these in a $50 class meter, really. Great work. Give them a pass on the fuses. I'm quite surprised to see those two, especially external access, on this $50 class meter. One thing you'll notice with the Fluke, though, is it's got the split input jack. So it's got the input jack alert there, whereas the cheaper meter doesn't have that. And these are pretty reasonable input jacks, par for the course by the looks of it. They've got shake-proof washers in there. But the input protection on this is surprisingly good. We've got no less than 5 MOVs here, whereas the Fluke's only got 3, and we've got 2 PTCs here compared to only the 1 over on the Fluke here, but they might have an extra path which actually needs the extra protection there. So I don't think they're paralleling those up. I'd have to check. That'd be unusual if they did. I'd have to check the exact layout. But yeah, so I think what's happening there is that they've got the 1 extra path here with the PTC, so you've got to have the 2 extra MOVs on that. So it's not like it's better input protection, it's just got an extra input path which needed protecting. And this is interesting. GT 17B plus. They've got decent diode input protection there against the fuses. Looks like they've got some protection transistors over here. That looks nice. And they've got the contact pads for the battery, which is excellent. But they don't have the big 1K high voltage input protection resistor, probably fusible, maybe fusible, not sure. They've just got the series SMDs there because, well, they're cheaper and simpler. They've got 2 arrays, and for all you MELF fanboys, there you go. There's that extra input there. There you go, coming from the PTC, and the MOV, actually that one there is not connected. Yeah, maybe that one there is connected onto here. And the 5 MELFs in a row to get the high voltage input string. But anyway, this is very clean. We don't know what is under the blob there. We've been blobbed. That says SD input. I'm not sure what that is. Is that, do we get like a serial output there? And the only the thing that's wired in here is the little backlight, just hand wired over there. That's a little bit how you're doing. But apart from that, it's a very neat construction. Very good for a $50 class meter, I must say. But it does lack, nicer detail, like the high voltage isolation slot here, and the big extra creepage slot protection here with the big raised, molded into the case plastic there. So yeah, the Fluke wins, no doubt, and it's going to survive overloads better than the Ziboo, but that's pretty decent. That's much better than I expected for $50. And it'll most likely meet its Cat3 600 volt rating. That's not really a question, I don't think. But yeah, I'm not seeing anything special in here that makes this like a 1500 volt class meter. So, you know, there's not much clearance there really on the input. So, you know, no isolation slots, nothing doing there. Anyway, I've taken the board out, and there's our contacts there for you contact aficionados. Neither here nor there. And if we flip it over, there we go. There's our contacts. And yeah, once again, nothing special, nothing wrong with it. But there is decent clearance between the inner ring and the outer ring there, so I don't mind that, which is the high voltage part of it. So yes, the Fluke is better built, it feels better quality, everything's better about it, but this one isn't bad at all. Anyway, the usual pro tip for putting these screws back in, don't just turn them in to plastic, turn it counterclockwise, turn it backwards until you hear it. Hang on. Click and drop into place, and then put it back so you don't cut a new thread. But even the screws are way better on the Fluke. It's just, yeah, no contest. And as always with cheap meters, there is no independent UL or CTL certification or anything like that, unfortunately. So it's just, yeah, trust me, bro. Not really a fan of the holster. You've got to sort of like get it, there's a little lip in there. You've got to sort of get it up and over, but well, you only have to do that if you tear it down, of course, which I'm sure you're all going to do. But this is pretty annoying. That's the most annoying holster I've ever seen, I think. Anyway, it's back on. Let's power it up. Ta-da! Oh, look at that backlight. Backlight's on. Is backlight always on by default? Backlight's always on by default. What's with that? I don't think I've seen another meter that has the backlight on by default. Wow. Alright, I contacted Ziboo and they said, yeah, the backlight does come on when you power it on. That's a deliberate design choice that they made. You can't disable that, but if you just leave it, it will actually switch off. So I guess I just wasn't leaving it long enough. So let's actually do this and turn it on, and then I'll start the timer and see how long it lasts. I'll get back to you. Oh, there you go. About 30 odd seconds. There. So there you have it. And we can just switch it on and switch it back off. But that's, I don't know, you're either going to find that annoying or you're going to find it useful. At least it's not constantly chewing the battery. That's the good thing. And I just manually switched it on. Let's see if it also will turn off at 30 seconds. Yes, it does. So looks like you can't keep it permanently on. So I know there are some people who like to keep it permanently on. So that's a downside. It looks like just holding it down doesn't latch it in any mode or something. Bummer. Anyway, if you compare the backlights here, yes, I can assure you I have switched that Fluke backlight on. It's barely there. So this backlight is way, way better. No contest. There you go. There's the two side by side. Similar sized digits, but these are way thinner. And the contrast, that's just not the camera. The contrast on the Fluke is way better. Way better. Let's give it a knock test. There we go. I can't, oh yeah, I can put some pressure on the LCD. Maybe, but that's all right. Well, there's nothing in the user manual about that, so I guess, it is what it is. Lucky it's got AA batteries, because that's just going to chew, like, every time you turn it on, if you don't want that, you've got to switch it off. I thought it might have something to do with this LED function here. I thought, oh, maybe if you hold that down or something, it would, like, latch it, but it doesn't. Anyway, there's nothing in the manual that tells you what this LED does, so that obviously does something extra. We'll find out. Well, there you go. I found out what that's for. It's for the non-contact voltage tester here, which, here's a mains plug, and so it beeps slowly when it's, and higher when it's close. So that's all right. That actually works decently. But yeah, that's what that LED indicator means. I mean, that's just... Now, given that we're already on the EF mode, we'll figure out this live mode here. If we press mode like that, then this will be a live function. Oh, the probe, haven't used it yet. It's got the, there you go, the extra Cat4 tip on it. If we probe that thing, it should do the live thing. Yep, and it beeps there. There you go. So it's a contact thing. That's quite handy. But check this out. It still works in non-contact mode. So, okay. As for the probes, yeah, nothing special here at all. Not gold-plated. They're not particularly sharp, and they're not silicone. They're just PVC. So, yeah, nothing to write home to your mum about. And if you're not a fan of the sticky outy angle thing, then, well, too bad. The probes do slip into the back here, but there's hardly any force at all. Like, they could really just easily pop out of there. So, like, just little pinky touch and they're falling out. So, not the best. Well, right off the bat, they have lied. I'm on the millivolt range, millivolts DC, supposed to have a 60 millivolt range. No, it doesn't. How do I get my 60 millivolts? DC volts, let's measure a voltage. Jump straight to 9.14, very nice, but it's only got a regular hold. It doesn't have a auto touch hold. But the Fluke doesn't either. I don't know why. Fluke invented that. And the min-max function, no, there is no average. It does not work on auto ranging mode. It only works on the fixed range. But that is the same with the Fluke as well. But one thing the Fluke has, as if you see my review, it does have that overvoltage warning indicator, which does come on at 9 volts. So I can show you that there. If I'm in max mode, boom, that comes on, showing you that it's over range. And it'll briefly come on during that auto range thing there, but then it goes off because it's not actually high voltage. So it's a combination high voltage auto range indicator. Oh, didn't realize I had the film on this whole time. Oh, sorry. There you go. For you film aficionados. I don't think that changes anything. And there you go. It did automatically come back on from the sleep mode there. Let's test the continuity, shall we? Oh, that's all right. And it lights up green. That's pretty good. Got a visual alert. It's not bad brightness. Thumbs up to the continuity tester. Latched, and it's decently loud. Excellent. Certainly better than the Fluke here, using the exact same leads. I am able to get that to miss. Like that. Whereas couldn't get that one to miss. And so the Ziboo was a bit louder, and there's no visual alert. But let's get official on that with the Ian Johnston continuity tester here. 10 milliseconds. Basically, can get a bit under that. You know, let's just round it to 10 milliseconds. Pretty quick. Okay, reference capacitor. 10.06, 0.6% out, but well within spec. Resistance standard here, that's 1 LSD out. 1 digit out again, no worries. 2 least significant digits out there. And it looks like we're 200 milliohms out there, but that's the lead. But the problem is, it doesn't have a relative function. I can't null that out. Urgh. 1 meg is bang on. 10 meg, near enough for Australia. And for those high input impedance on millivolt mode aficionados, sorry to tell you, it's 10 meg. Whereas if we swap it over, the Fluke actually, it actually has a high input impedance on it. You ever like that? Or you don't? It's neither here nor there in this class of meter. Doesn't matter. Okay, ohms auto ranging speed. I got both meters connected in parallel, so that's why we're getting a reading there. Don't worry, there's nothing actually wrong with that. It's just the idiosyncrasies of the input circuitry. So, yeah, let's give it a go. Boom, the Fluke's already there. The Ziboo's a little bit slower, but not by much. But, yeah, it's not a particular speedster. And interestingly, the Fluke has leading zero blanking. The Ziboo doesn't. Then again, Bryman are also famous for not having leading zero blanking. Let's try 1000 microfarad electrolytic cap. I'll do the Fluke as the reference here. So, you're going to have to twiddle your thumbs. I'll get back to you. Boom. Almost 12 seconds there for Dan measuring 943. Okay, the Ziboo. Let's go. It's not giving you any indication, which is a bit annoying, but oh, there we go. Oh, 6 seconds. Twice as fast. Diode test compliance voltage, quite low, 2.1, considering that it's got those 3 AA batteries. And if we swap that around, we'll find the Fluke with its 2 AA batteries is actually higher at 2.3 volts. So, bit of a downside there. Let's measure a diode, and you get no audible or visual indication or anything like that. But you don't get that on the Fluke either, so neither here nor there. One thing I did notice is that, look, we're in diode mode, or let's say if you always wanted to be in continuity mode by default, if you switch it and you go back, you lose that default range. Now, you either like that or you don't. So, for reference, the Fluke does exactly the same thing. And we'll put mains up the clucker, we'll measure the duty cycle there, and we can measure the Hertzkeys as well. So, there you go. Well, mains is a bit out today. But it seems to only have 400 Hertz maximum, so, This is interesting. Have it on DC volts, you try and measure AC, the mains here, it just flashes back and forth. Kind of rather like that. Whereas you do the same thing on the Fluke here, and volts DC, we're actually like measuring 0.2 volts, so that's erroneous. Yeah, I do actually prefer the Ziboo in that case. And you'll notice it does have a high voltage indicator up there, but why? It's got the LED there, why it can't flash that LED as well, like red. I would have, that would have been a nice touch. Fix it in firmware maybe? Okay, standard overload test, 240 volts AC mains up the clacker. Let's go to millivolts there. Let's go to Hertz. It measures that, of course. Let's go to the ohmskis there. Our PTCs will be heating up a little bit. Let's go to your capacitance. Let's go to your current ranges. And they're up. Yep, there you go. And let's go back. And up. No, see, it defaulted to the DC thing. But there you go. It's fine. And with the reference cap, you can see that we haven't destroyed anything, but you'll see that this is just dropping because, as I said, there would be some PTC protection in there that was heating up a little bit. Now it's dropping back down. Entirely normal and protected. Nice. 600 millivolts. Check. How far can we go above that? Can't go to 700. Ooh. Can't go to 6.1. Here we go. How many counts? There you go. Well, yep. Wow, the 6 volt range significantly out. Look at that, 12 counts out. But actually, that's within spec. That's still 0.2% at 6 volts. So that's interesting. If we go down to 5, yeah, and trust me, that is all zeroed. There's nothing wrong with my metrology standard here. Can assure you, gets better when it's down at the lower part of the range, but like full scale is where you want it. Oops, it's got a rescale there. Yeah. Okay, AC. That's again, yeah, 0.2%. But on the low side this time. Well, that's better at 6 volts. And it's pretty good at 60 volts too. Let's go to 600. Okay, it's going to beep at us now. But yeah, 600 is bang on. But this baby can go up to 11. What? There we go. So much for the 1500 volts. There you go. Can do 1000 volts AC, but 1100. Can't do 1100. Oh, and I've got it hooked up to my DC standard, and it'll measure 1000 volts. Will it measure 1100? Yes, it will measure 1100. That's as far as I can go. Well, no, actually, I can go a little bit higher than that. But that's about 1200 volts. Okay, so I might get to 1500 volts DC, but it won't do it AC. Understandable. But as I said, I didn't really see anything in the construction of this thing that makes it out to be like a class above other typical multimeters which stop at 1000 volts. So, yeah, I don't know. They claim 1500 volts. I'm going to have to actually do a review of a teardown of a true high voltage, higher voltage multimeter. But yeah, I don't think there's anything special in this. I don't know why they're rating it for 1500, but yeah, it'll probably do it. But
60 milliamps, there you go. That's not too shabby. 6 milliamps. No, we need to auto range. We need to range that. There you go. Yep, no worries. And it's about 0.5% out there on the 600 microamps. Bum that it doesn't have a 60 microamp range. That would have been nice, but neither does the Fluke. And, you know, at this price point, well, what do you expect? But it didn't have that 60 millivolt mode, though. Disappointed about that. All right, we've got the i600E current clamp here. This is 20 Yankee bucks, so very reasonably priced. And here it is here. It is in the Fluke yellow. How close is that? How close is that? Trademark lawyers in the comments. Wow. Anyway, it does come with a pouch, which actually kinda just fits the multimeter. Would have been, I don't know if you'll get your probes in there as well, maybe. Would have been nice if they made it slightly bit bigger and it actually fitted the multimeter as well. That would have been cool. Anyway, it's got your usual clampy jaws, pretty good. It's rated for 600 amps maximum. Will give you 600 millivolts, 100 amps, 100 millivolts, 10 amps, and a 1 amp at 1 millivolt. So it's not for low current, it's for big current jobbies. And there's no batteries in this, it's just a current transformer. So you can use this with any multimeter. It doesn't have to be this one. So if you just want to buy it on its own, but most of them will have the current, like, you know, you can just use the millivolt range, but this one actually has a specific current clamp mode. There it is, amps AC and amps DC. And it looks like we can't range that thing. So it's like 600 amp mode and that's it. That's a bit disappointing. Even though it allows me to do DC over here, it doesn't work. Trust me, I have 10 amps flowing through there. There it is, 10 amps on channel 2 there. But it's an AC clamp only. But of course there was no point testing that because this is a batteryless unit, and of course you can't get a DC Hall effect current sensor with no power source. AC you can, of course. It's going to work because it's just a current transformer, but for DC, no, you're going to need a battery in there and to actually power the sensor and the amplifier, and it doesn't have it, so it's AC only. But of course it doesn't claim to be DC, but the multimeter allows it. I don't know, do they have another clamp accessory that's for, you know, has a Hall effect for DC? I don't know. So, you know, 2.5%, 20 bucks might be useful for someone, but and the super advanced teardown, there it is. They do actually have a little trimmer in there, but yeah, that's all she wrote. It's just a current transformer. Okay, battery consumption. What do we get? Let's switch it on. Backlight on first. I've got the full 4.5 volts there. There you go. 14 odd milliamps with the backlight. I assume the meter takes a couple of milliamps, maybe 4, so maybe set for 10 milliamps backlight there, but we can find that out. Yeah, 1.7 milliamps on DC. Go to AC mode, 1.7, it's the same. Don't expect any more over here. No. There you go. So that's not too shabby. So backlight, about 12 milliamps. That's all right. So let's wind the voltage down. 4 point, yeah, we can see that. See where it switches, the low battery indicator comes on at. Okay, we're at 3 volts. Hasn't come on yet. 2.5, whoa, there we go. Whoa, that dropped out quick. Okay, 2.61 volts. It turns on, but it doesn't do the backlight thing because it hasn't got a high enough compliance voltage. And that's interesting. At 2.6 volts, there's no, where's the low battery warning indicator? That's a bit, how you doing? There you go, you can see the backlight start to turn on. Oh, what, this thing doesn't have a low battery indicator? What? That's at like 1 volt per cell now, 2.9 volts. Sometimes the battery indicators can take like a while to like sense it and switch on, which is okay. There's nothing inherently wrong with that. Let's power this thing on here and see. Yeah, it's got a battery indicator down in the bottom corner. Look, there it is there. Okay, what I've got is a 6K resistor on there, and we're at 4.5 volts. So I'm now going to adjust that voltage, lower it, and see at what point it should, well, you know, you'd expect to see maybe some discrepancy. But a good, you know, any good meter should hold out until it's low voltage. Our backlight's going out. So I guess you could use the backlight, doesn't it? It's still holding in there. Look at that, at 2.8 volts. That's well under 1 volt per cell. Wow. At 2.5, it's still, it turned off. It turned off at 2.5. Oh, there we go. The battery indicator is now on. So it looks like it takes a while for that battery indicator to turn on. Okay, it just switched off at 2.7. So at 2.6, yeah, it's okay. It's come back on. Why did that not work before? So there you go. But your backlight doesn't work. Well, it's there, but it's tiny. But there you go. It's holding its accuracy right down to 2.6 volts. That's actually quite remarkable. Yeah, that's definitely confirmed. At 2.7 volts, the battery indicator will not come on. So you're extracting almost the entire capacity of these batteries, which is quite remarkable. We could be talking 1,000-hour class battery life multimeter here. So 1.5 milliamps, I mean, I'll put up a curve here of a, say, like a Duracell curve at 5 milliamps constant current discharge. We're looking at 700 hours plus. So this is well under that 5 milliamps. So we could be talking 800, 900, even 1,000 hours battery life from this thing. It looks like, yeah, it's in that class. Wow. This is great. But some people will ask, well, can I use lithium AA's in here for even longer battery life? I don't know, what would you get, 1,500? I don't know, 2,000? Maybe not, but, you know, well over 1,000. Well, let's wind the voltage up to 5.1 because you'll get a higher terminal voltage on those, and that seems to be working fine. It's measuring our 6K resistor there, and the current hasn't increased. So, yeah, confirmed. You can use lithium AA's in this thing. Great. As for the temperature, well, that's like the cheapest, wimpiest looking thermocouple I've ever seen. But anyway, it's going up. So it does, you know, it works to a couple of degree accuracy. It's 22 degrees here in the lab. It said it was 20, but if we pull that out, it does actually read ambient. Fairly, there you go. Bang on for ambient. As you saw in the teardown, it doesn't have a proper true RMS chip in it. You don't expect it for this price range. This Fluke certainly doesn't have it. We're about 3 dB down at 4 kilohertz there. I've got 6 volts nominal there, so there's the 1 kilohertz. Now, it does actually have a VFD mode, or variable frequency drive mode, so we can actually switch that on, which adds in that's why they've got the 1,000 hertz there, that adds in a 1 kilohertz filter there, but you can see that's only fixed on the 600 volt AC range, so you can't use it on smaller ranges. So obviously if I go up in frequency, it's like we don't get the same bandwidth we did before. So yeah, they're just adding in the frequency there for variable frequency drives. Oh no! Oh, oops! Why does this keep happening? Oh no! Whee! Oh! Oh, right on the range switch. I think it survived. No wuckers. So there you have it. There's the $50 Ziboo versus the $150 Fluke. And it's not a bad little meter, but it does have, you know, a few early limitations. Like, I'm not sure what's happening with that 6 volt mode. I mean, it's within spec, but it was 14 counts out, and really out of the factory, here in a, you know, lab temperature environment, you expect that to be, you know, only a few counts out, straight out of the factory. So not sure what's doing there. Needs that relative mode. Without that, a lot of people aren't going to like it. And you can't latch the backlight, and it does just turn on, so that might annoy a few people, I think. But the good news is I've been talking to Ziboo, and they are very open to user feedback on this thing and how they can improve it. Unfortunately, if you buy this thing now, you can't do a user firmware update on it, as far as I know, because, well, they won't tell me what chipset is used, let alone, you know, I don't even know if it's reprogrammable flash or not. So basically, you buy it and you get what you get and you don't get upset. But that's the same with practically every multimeter on the market, including the Fluke here. And do not buy this thinking that you're getting a 1500 volt class meter, because as I said, I didn't see anything inside this thing that warrants, the extra 500 volts over any other meter on the market, including the Fluke here. Yeah, it might work to that, but it's not like it's a specific high voltage, solar, industrial meter or something like that for working in the high voltage DC industry. And it could have had a bit faster updating, I think, but it's par for the course for normal meters. But for 50 bucks, I like the fact that it actually has accessible fuses and looks like they're real ceramic 1000 volt jobbies. So that's great for a $50 class meter, but yeah, there's nothing special here. So, you can probably get better bang per buck in one of the Anings or something like that. But as far as like a competitor to the 17B goes, it's not too shabby. It's just missing a couple of features. It'll probably improve in future variants. Almost 3 times the price. Although, this is a Fluke. Nobody's going to question you if you walk onto the work site and you got the Fluke yellow. But if you got the Ziboo red, it's not quite the same. If you got the EEVblog blue, everyone's going to think you're a champion. So I'm sure you could do a lot worse than buying a 17B Pro Ziboo, but I like, if you're looking for battery life, it looks like it might do that. It might be a killer for that. Just whack some lithium AA's in there and you might actually get 2000 hours out of this sucker, which is really quite something. Thank you very much, Ziboo, for sending that in. It's not a bad meter at all. I don't mind it. It's quite a rugged little safe meter for 50 bucks. Just would have been nice if it had just a little something extra, but yeah, it doesn't seem to have that little something extra. As always, you can discuss down below and over on the EEVblog forum, which is Test Equipment Central. And if you go to eevblog.store, if you want the EEVblog blue, we got some deals over there. But they're not 50 bucks though. Sorry.